Hello everyone, welcome to IS 300 and today's discussion of related technologies. Throughout the semester we have talked about platform as a service, software as a service, and infrastructure as a service. We've talked about the security implications of those architectures. Today we talk about some of the related technologies which are very important with regard to cloud computing. Those are big data, the Internet of Things, mobile computing, and serverless computing. We also provide some recommendations at the end of this discussion. Related technologies have their own particular security issues and concerns. Software-defined networks, which is what we're talking about when we're referring to cloud computing, and containers, those are very tightly intertwined, tightly related. Overlapping technologies will frequently rely on cloud deployments, and that brings additional security implications. Related technologies will fall into two categories. One, technologies that rely exclusively on cloud computing to operate, or almost exclusively, and technologies that don't necessarily rely on cloud computing, but are commonly seen in cloud deployments. And those are the four, again, that we mentioned earlier: big data, the Internet of Things, mobile devices, and serverless computing. We'll start with big data. It is defined as high volume, high velocity, and high variety. High volume because of the number, the terabytes and gigabytes and exabytes of data that is collected on a daily basis. High velocity because it's very high speed, fast data processing in real time or streaming data is an example. High variety can be structured or unstructured data that, for example, is posted in a social media platform, Facebook, Twitter, blogs, and that type of thing is considered unstructured data. And as you know, we generate tons of unstructured data on a daily basis using social media platforms. Cloud computing is ideal for deployments where big data projects are part of the equation. Big data typically relies upon cloud computing. Three components of big data. It is distributed data collection, which means that the data will be deployed through a variety of different network configurations. From one user to the next, it might take on a very different configuration. Geographically dispersed distribution of data. Distributed storage. We talked about Google file system and Hadoop file systems, which are all distributed. We've also talked about NoSQL, not only SQL, which is for very large data sets. And so distributed storage is part of big data. Distributed processing, tools that make distributed processing a lot faster. Spark for Apache services, for example, and MapReduce, which is a Hadoop application, both used for speeding up data processing, very ideal for big data. Big data has several concerns. They're listed here. Security and privacy is a big issue. The collection of the data and the securing of that data. Key management typically implies that it's going to be encrypted, and the encryption keys have to be distributed to multiple storage and or analysis nodes. Security capabilities of the cloud must accommodate and include big data technologies. Identity and access management should occur both at the cloud level and the tools which are used for big data, which increases the complexity significantly, because now you've got not only the infrastructure to secure, but you also have the data itself to secure. and very large volumes of data at that. Platform as a service is usually running on a provider's infrastructure, and in the case of big data, there may be some machine learning, some artificial intelligence kind of technologies where the machine learning can run on the platform as a service inside of the provider's infrastructure, which means that the employees now have access to the machine learning applications, which could introduce another potential security hole. The Internet of Things is yet another whole different level of complexity that is added to cloud environments, because these Internet of Things devices, the IoT devices, are often connected using the cloud. Devices, non-traditional computing devices used in a physical world using the internet for connectivity. That introduces another set of security issues. The Internet of Things devices, IoT devices, typically for supply chain management, logistics, customer relationship management, CRM, marketing, retail, healthcare, lifestyle applications, and things of that nature are used commonly by IoT devices. Many of these devices connect to a cloud computing infrastructure for back-end processing and data storage, thereby introducing another point of security concern, another potential security hole, which is only as good as the configuration and security of the devices themselves. The key security issues related to IoT, securing the data and sanitizing it, authentication and authorization of those devices. Sometimes there's an API call directly to the API, and the API might use stored credentials. Stored credentials, as we have referred to in previous chapters, is a no-no, because if somebody is hacking into a device, they get access to the API, there are the stored credentials, the password, or whatever other authentication mechanism that is being used, and that thereby making the API the potential security hole. Encrypting communications is critical. A lot of IoT devices, either they don't use encryption, or they use weak or outdated encryption. And of course, the lack of encryption or the reduction in the capability of the encryption is a potential security hole as well. Patch management. Most devices come shipped as is. They don't receive the security updates. They've been sitting on the shelves for months, and the new patches have come out, but the devices sitting on the shelves that are going to consumers do not get updated. So when you receive a device, it's probably already out of date, needs to be updated, but that's only as reliable as the user who is installing the device. Security incidents have happened as a result of IoT devices that have not been updated. Then you have mobile applications and mobile devices. Of course, that also introduces another layer of complexity, BYOD, bring your own device, which then allows for mobile users to connect their tablets, their smartphones, and other devices to the network. And of course, then registration of that device, authentication and authorization of that device becomes very important, and especially when there are cloud providers and infrastructures that are using APIs, application programming interfaces, with possible stored credentials. Again, stored credentials should not be part of an API at any time. Data stored on multiple devices. You should assume that the user of the device is a hostile attacker, even inadvertently. Maybe the user is unaware but the device has been hacked because of the lax security. So it's important to make sure that authentication, registration, and all of those things are required. Maybe two-factor authentication might be a good idea for mobile devices that are connecting to cloud environments. Application APIs, also a big problem because attackers know how to use sniffers to connect, to look at API connections, realizing that maybe those connections are unencrypted and possible holes that can be exploited for security weaknesses. Certificate pinning and validation inside of the device might reduce some of those risks. Serverless computing is somewhat of a misnomer because the servers are there, but the servers are hidden from the users. So the user does not have access to the physical hardware. They rather have access to software, and then they take advantage of platform as a service capabilities, which are running in a cloud environment. They are not customer managed operating systems or containers, but servers that then allow for the configuration and security to be completely hidden from the cloud user. The consumer manages the settings for the service and not any of the underlying physical hardware, servers, and so on. Hence the term serverless computing. Here are the recommendations. Follow your cloud provider's guidance on authenticating applications and designing applications that connect directly to the cloud. Using industry standards. Federated identity, which basically is single sign-on, and two-factor authentication to make sure that the person who is gaining access is the person who should have access. No unencrypted devices, or never transfer unencrypted keys or credentials over the internet. Test your APIs under the assumption that a hostile attacker will have unencrypted access. And again, certificates and validation is important. Validate all API data and sanitize it. Make sure you don't have any stored credentials in your APIs. Implement server and cloud-side security for hostile API activity. Ensure that all devices that are used on the network are secure and that they have implemented encryption. Sensitive data that could allow compromise of the application stack should not be stored locally on a device, on a mobile device specifically, where a hostile user can potentially gain access to it. With serverless computing, again, make sure that the services that are being used have been matched against the compliance requirements and or the standards and or any regulations of the industry that need to be addressed to make sure that your services are responding and meeting requirements of those regulations. Consider using architectures that will reduce or eliminate attacks. Know that the cloud user is responsible for incident responses for serverless deployment. When we're talking incident responses, that means an incident has already occurred, but how the user responds is also very important. The cloud provider is responsible for security below the platform at the infrastructure level. The cloud user is responsible for proper configuration and the use of the products above the infrastructure.